Alright guys, so what we are going to do is finish off what we started today, so acid-base titrations. Last time we talked about titrations, we were talking about how to neutralize acids with bases or neutralize bases with acids, and we talked about calculations mostly in terms of how much exactly base we would need to titrate or to completely neutralize some amount of acid. What we're going to be talking about now is focusing on the points of a titration. So if you have your lecture slides with you, you should have some page that looks like this, where we have a titration curve. A titration curve tells me about the pH of my solution, which again is a measure of the amount of H3O plus in solution versus the amount of either acid or base added during the titration. So we're going to assume that my original solution is some acidic solution and that I'm going to be adding some amount of sodium hydroxide, a base, to my acidic solution to titrate it. So if I start with an acidic solution, it's all acid, my pH to begin with should be relatively low. So I start at a low pH, and as I add more and more sodium hydroxide, my pH should be increasing. Now, I talked about this in the very beginning when we talked about acid-base titration, but there are a couple of points that we have. So, the first point that we reach is called the equivalence point. The equivalence point, hopefully you guys can see this, equivalence point is the point at which we have the same number of moles of acid as number of moles of base. So, if I have maybe hydrochloric acid in here, 1 mole of hydrochloric acid, my equivalence point would be when I have added 1 mole of, oopsies, this is starting to get too low. Change that. Here we go. When I have added 1 mole of sodium hydroxide. Now, for a strong acid, strong base titration, the equivalence point would be neutral, a pH of 7, because I have added equal moles of strong acid and equal moles of strong base, meaning I have completely neutralized all of my acid with base. So, when I'm looking at my titration curve for a strong acid and a strong base, my equivalence point, again, should be at a pH of 7. Originally, in the beginning, I should have a nice low pH because I started with an acidic solution. After I reach the equivalence point, if I continue adding more and more base, my solution's pH should keep increasing to some point. I should be at a pH above 7 as I add more and more base. My solution is now basic. So that's kind of the general idea of really a titration curve, which again is plotting amount of base for an acid titration versus the pH of my solution. All right,